Hi everyone, today I'll be talking about inheritance and typecasting. So first, let's talk about inheritance. Inheritance can be roughly represented by this picture over here. So this picture over here actually shows the relationship between superclass and the subclass, with the subclass actually containing the superclass. So why is it like this and not the superclass containing the subclass instead? So let's see an example using Swift. So inside Swift, we know that there is this thing called UI button, and inside the UI button, there are predefined functions like set title, set image, and there are also predefined variables like background color and alpha. So let's say I'm now trying to create a new class with the name custom button, and then this I subclass UI button. So when a subclass UI button, right, this custom button can actually have all the functionalities of UI button. So I can call set title from custom button, and I can call set image. I can also call background color and alpha from custom button. In addition to all of the functionalities of UI button, I can actually define my own function and define my own variable that is actually not reachable from UI button. Okay, so that is why the custom button, that subclass UI button, is a bigger circle that contains the UI button, which is the superclass of custom button. Okay, so another representation of inheritance is actually something like this. So animal is a superclass, and then cat and dog will be the subclass of this superclass. Mm, let's say we define some functions inside an animal. So an animal can eat and then can move. Okay. So when I create a cat class and then I subclass animal, this cat will also get all the functionalities that an animal can do, which is eat and move. In addition to that, I can define my you know own function that is specific to cat. So for example, I define a function can see in the dark. That is something specific to cat, right? Um, so similarly for dog, I inherit from animal, so I will have functions like move and eat, functions that is defined inside the animal, and in addition to those functions, I can define something like likes to eat bone, something that is specific to dog. Okay. Now let's talk about typecasting. There are two types of typecasting: upcast and downcast. When someone says upcasting, they are actually referring to a subclass being treated as its superclass, and downcasting is the other way around: a superclass being treated as its uh, what do you call subclass. Okay, I have to highlight this to you. Casting does not actually change the object. We are just treating or labeling the object differently. So let's say I have a cat. You know that this is a cat. But when I say I'm treating this cat as an animal, I will not expect this animal to be able to see in the dark, because I'm treating it as a more general thing now. But it is still a cat. I know that I know that it is still a cat. It's just that I'm treating it as an animal and not as a cat. Okay, so that is what this sentence actually mean. Okay, so now let me bring you to these two bullet points over here. Upcasting can never fail. This is true because we are going from specific to general. A cat will always be animal, and a dog will always be animal. So upcasting can never fail. Okay, you can always treat cat as an animal, and you can always treat dog as an animal. But downcasting can fail. So for example, I have an animal. I'm going from general to specific here. So I have an animal, and then I'm treating this animal as a cat. But what if the animal is actually a dog? So the function that you are calling, for example, you want to call, because you are treating it as a cat, you want to call can see in the dark. But actually, you don't have that function inside the object because that object is actually a dog. Okay? So downcast can fail, but upcast can never fail. Okay? Now, let's see some example that is more closely related to Swift. So I have a view here, and then this view is of type UI view. And then I'm assigning a custom view object into this view. So this custom view we know is actually a subclass of UI view. And then what is happening here is actually the custom view is upcasted to UI view before being assigned to view. Okay, um, if this analogy may help, I will do I will treat custom view as a dog and sorry, custom view as a dog and UI view as an animal. So I know that this object is a dog object, but I'm treating it as an animal instead. That is what is actually happening here. I have a custom view, which is a subclass of UI view, but I'm treating it as a UI view. That is what is happening here. So we can always, in this case, in this scenario, we can always downcast it to custom view because we know that the original object is custom view. So when I want to call something like a function or like a variable that is specific to custom view, but the function and variable are not present in UI view, I have to actually downcast it to custom view and then call the function or variable. I will show you later in Xcode. Now, a second example here is that I have view that is of type UI view, but instead of assigning it custom view, I'm assigning it a UI view. So I'm assigning an animal object to an animal type. In this scenario, I will not be able to downcast it to custom view or any other class that subclass UI view because this is a general thing. It's like saying, I have an animal, and then we have discussed before that you cannot, downcast animal to dog. Okay, because this is more general and dog is more specific. Okay, so we are done with the explanation. Let's go to our Xcode and see how this is actually implemented. We see here view as main view dot delegate equals to self. This is let me get my cursor out. Okay, so as here is actually Swift syntax to either upcast or downcast. So if you see this, this means I'm downcasting view to main view. Let's discuss first about this line over here. So we know that view is of type UI view, okay, and then we are assigning main view to view. So what is happening here is actually we are upcasting main view object to a UI view. Okay, so what is happening is actually something like main view as UI view. We upcast it to UI view before assigning it to view. This is what is actually happening. But why do we not have to do this? That is because of this. Upcasting can never fail. So since it can never fail, I do not have to specify what class I want to upcast main view to, because the program will know that obviously I'm upcasting it to UI view and nothing else. That is why I don't have to define what I want to upcast it to. Now, it's different scenario when we want to downcast it. When we want to downcast it, we have to explicitly say what we are downcasting it to, because as I mentioned before, downcasting may fail. Okay, so let's say I want to do this instead. View.delegate equals to self. This will give me an error. It says value of type UI view has no member delegate, and this is actually very true. We can see this from this picture over here. So your UI view is actually here, and then because my main view, subclass UI view, my main view will be here, and then the delegate variable is actually somewhere here outside of this UI view. So the UI view can never reach it unless we downcast it first to main view. We downcasted it to main view, and then we'll be able to access the delegate variable over there. Okay, so we have discussed almost everything. The last thing that I want to show you is that what if what if I downcast this view to not main view but create view. I mean, my create view also subclass UI view, right? So let's try to downcast this view as create view instead. So we do something like view as create view on, and we assign this to something wrong equals to this. Okay, now let's run the app and see what happens. Okay, let's see what happens. And yep, as expected, this crashes because it says that the object is actually main view and you are trying to downcast it to create view. Um, let's imagine this main view as a cat and create view as a dog. So although I'm treating this cat as an animal, I will not be able to downcast this animal that is actually a cat as a dog. Okay, that is why it gives you the app crashes, and you can ignore this. Basically, it just says that, oh, you are defining this variable, but you are never using it. So why not just do this instead? But because this is demo, for demo purposes, I will not actually be using that. Okay, so I think I have explained what I need to explain about inheritance and typecasting. Hopefully, you find this useful for your project. Okay, thank you.